5 days ago, astronomers announced they'd found a planet hiding inside one of the most photographed, most studied star systems in the entire night sky. Not a system nobody had looked at closely. The opposite, one of the most intensely observed planetary systems we know of. And a giant planet had been sitting there, unnoticed, the whole time. Here's the part that should genuinely unsettle you. They weren't even looking for it. They were pointing one of the most powerful telescopes ever built at a target they already understood, trying to answer a completely different question, when something that shouldn't have been there showed up anyway. The star is called Beta Pictoris, located 63 light-years from Earth, and astronomers have been studying it closely for decades. It's young by stellar standards, only about 23 million years old, still surrounded by a dramatic disk of dust and debris left over from its own formation. 2 giant planets were already known to orbit it. Beta Pictoris b, one of the very first exoplanets ever directly photographed. Back when direct imaging of any planet outside our solar system was still a genuine milestone rather than a routine achievement. And Beta Pictoris c, confirmed years later, using a different detection method entirely. Between them, this system has been treated almost like astronomy's favorite laboratory for understanding how planets are actually born. Precisely because we can still see the raw material, the dust and debris, that the planets formed out of, still swirling around the star in real time. On July 15th of this year, a team led by Aidan Gibbs, a postdoctoral researcher at UC San Diego, announced a third planet in the system, Beta Pictoris d, published in the Astrophysical Journal Letters. That makes Beta Pictoris only the second known planetary system, with at least 3 directly imaged planets around it, anywhere in the galaxy. The newly found planet is estimated to be at least twice the mass of Jupiter, making it the smallest of the 3 known giant planets in the system, though still enormous by any ordinary standard. Modeling suggests it orbits at roughly 30 astronomical units from its star, comparable to the distance Neptune sits from our own Sun, making it the widest orbit of the 3 known planets, while still remaining just inside the inner edge of that famous debris disk. But the story of how they found it is stranger than the discovery itself. The team wasn't hunting for a new planet at all. They were using the James Webb Space Telescope's NIRSpec instrument to study the atmosphere of Beta Pictoris b, a planet they already knew existed. Specifically, they were using a mode called an integral field unit, which captures both an image and a full light spectrum from every single pixel simultaneously. While analyzing that data, something appeared that had no business being there. Gibbs later described the moment simply. They weren't looking for anything new, and then an unmistakable signal showed up exactly where they didn't expect one. That signal wasn't a bright dot of light, the way planets are traditionally discovered. It was a distinctive pattern buried inside the spectrum itself, a series of peaks and dips scientists compare to a barcode, caused by carbon monoxide absorption in a planetary atmosphere, where the team expected to see a smooth, boring spectrum from starlight simply bouncing off dust. They instead found the unmistakable chemical fingerprint of a planet. Because a spectrum carries more than just chemistry, the team was also able to extract the object's radial velocity, essentially, how fast it was moving and in which direction. That measurement confirmed the object's speed, position, and alignment matched something genuinely orbiting Beta Pictoris, ruling out the possibility that it was a background star or an unrelated object that just happened to be sitting in the same patch of sky. Jean-Baptiste Ruffiot, a research scientist at UC San Diego and principal investigator on the observation, put it simply: bright, Unexplained blobs of light show up in telescope data all the time, and experienced astronomers have learned not to trust them at face value. They're often instrumental artifacts, or structures in the dust disk that only look like something more interesting. What made this case different was having a full spectrum captured at the exact same moment as the image, turning a suspicious blob into a confirmed discovery almost immediately. Follow-up observations using Webb's separate MIRI instrument later detected water vapor and methane in the planet's atmosphere too, adding even more confidence and giving astronomers their first real look at what this newly found world is actually made of. Here's why the planet stayed hidden for so long, even inside one of the most heavily observed systems in the sky. Beta Pictoris happens to sit inside one of the brightest, dustiest debris disks known to astronomers. That dust behaves almost like fog, scattering the star's light in every direction and making it extremely difficult for traditional imaging to tell a planet apart from the swirling structure around it. The spectroscopic method the team used essentially ignored the fog entirely. Instead of trying to see a point of light through the haze, they searched for narrow, specific chemical signatures that only a planetary atmosphere would produce, signals dust simply doesn't create. That distinction is what finally let Beta Pictoris step out of hiding. There's a satisfying piece of foresight buried in this discovery too. Astronomers studying Beta Pictoris's debris disk had noticed for years that its inner edge was unusually sharp and well-defined. The kind of structure that's normally explained by an unseen planet, gravitationally shepherding the dust into place. Researchers had already predicted that something like Beta Pictoris d should exist, based purely on the shape of the debris disk itself, years before anyone actually detected it directly. A separate team, led by researchers at the University of Edinburgh and the European Southern Observatory, independently confirmed the same planet using entirely different instruments. The European Southern Observatory's Very Large Telescope, combined with Webb's NIRCam camera. Two independent methods, converging on the same previously invisible planet. What makes this discovery matter beyond just adding one more planet to the catalog is the method itself. This is being described as the first directly imaged planet discovered primarily through spectroscopy rather than traditional coronagraphic imaging, meaning astronomers can now potentially find planets hiding inside dusty, complicated environments simply by reading their chemical signature, rather than needing a clear enough view to physically photograph them. Every dusty, debris-filled star system astronomers have already scanned and dismissed as no visible planets may be worth a second look. The fog that hid Beta Pictoris d for years might simply be standard interference for a method that, until 5 days ago, nobody had fully proven could see straight through it. There are dozens of known debris disks around other young stars, many of them studied for exactly the same reasons Beta Pictoris has been, and any one of them could be hiding a planet the same way, simply waiting for someone to stop looking for a point of light and start looking for a chemical signature instead. We've spent decades treating Beta Pictoris like a system we already understood, photographed and studied since before most currently active astronomers even started their careers. And it still had a giant planet, roughly twice the mass of Jupiter, quietly orbiting inside the dust the entire time, waiting for the right instrument to finally ask the right question. Beyond the visible, beyond what you can see, but never beyond what you can understand. Subscribe because next time we go beyond again.